Now we're going to look at our second task, which is solving some equations. So if we have n squared minus 2n equals 99, Tyler wrote down some steps, and we have to analyze his work. So write down what Tyler did in each step. So if I look at n squared minus 2n equals 99, and then from here, I have 0 on the right-hand side. So it looks like 99 minus 99 made 0. And then I had like a plus 0 here and then minus 99. So for step 1, it looks like Tyler subtracted 99 from each side. So now if I have n squared minus 2n minus 99 equals 0, it looks like he wrote and was looking for factors of negative 99 that added together to be negative 2. So he found n minus 11 times n plus 9 equals 0. Let's just double check. I know that negative 11 times 9 is negative 99, and negative 11 plus 9 makes negative 2. So it looks like for step 2, he factored the standard form n squared minus 2n minus 99, and he put that in factored form. Then here, he set both equations equal to 0, so n minus 11 equals 0, and n plus 9 equals 0. So he set both equations equal to 0. Then it looks like he added 11 to both sides and then subtracted 9 from both sides and solved. So now you have to solve each equation by rewriting it in factored form and using the zero product property and showing our reasoning. So here, I need factors of 15 that add together to be 8. So if I'm doing that, factors of 15 are 1 and 15. So if I add those, that makes 16. So no. The next thing that goes into 15 is 3. And 3 times 5 is 15. And if I add 3 and 5, it makes 8. So this equation we could write as x plus 3 times x plus 5 is equal to 0. And it moves from standard form to factored form. And then using the zero product property, we could set both equations equal to 0. So I would set the first factor equal to 0, x plus 3 equals 0, and then set the second factor equal to 0, and then solve. So x equals negative 3 here, and x equals negative 5 here. So in looking at the second equation, we're going to have to do a little bit of work here because in order to factor an equation, we need it equal to 0. So I'm going to subtract 5 from both sides. And I would have x squared minus 8x plus 7 is equal to 0. And now I need to factor that. And at first it looks like that's not possible because I need factors of positive 7 that add to be negative 8. But then as I think more deeply about the problem, I know that I could do a negative times a negative to make a positive. And when I add a negative and a negative, it can make a negative. So the only factors of 7 that could be both negative are negative 1 and negative 7. And then when I add those, negative 1 plus negative 7 makes negative 8. So to factor that, I could have x minus 1 times x minus 7 equals 0. And then setting both equations equal to 0, I have x minus 1 equals 0 and x minus 7 equals 0. And then adding 1, I have x equals 1 and x equals 7. Similarly, for number 2, if I have x squared minus 10x minus 11 equals 0, I need factors of negative 11 that sum to be negative 10. Now, looking at this, to get a negative, I know that I'm going to have a positive times a negative. And when I add them, it's also going to be negative. So I know that the negative factor has to be bigger. So I'm going to try and pick x minus 11 times x plus 1 and have those equal to 0. So I know that x minus 11 equals 0 and x plus 1 equals 0. And then in solving this, I would get x equals 11 and x equals negative 1. So we're going to look at D and E. So for D, I notice that I have a perfect square minus a perfect square. So if you remember from our previous lesson, to make 49, I could write that as 7 times 7. So our first term is going to be 7 and 7. And then a minus a perfect square, we actually do a plus minus combination. And if I multiply x times x, it makes x squared. So this factors into 7 plus x times 7 minus x is equal to 0. And then setting both factors equal to 0, we have 7 plus x equals 0 and 7 minus x equals 0. In solving this, I know that 7 plus negative 7 equals 0. So x is going to equal negative 7 here. And you could subtract 7 from both sides and say 0 minus 7 is negative 7. And then also here, I know that 7 minus 7 equals 0. So if I plug x equals positive 7 there, that would also work. Now, this problem is going to become more difficult. So in order to use the zero product property, I have to have this positive 30 equal to 0. So what I'm going to do is expand this, subtract 30, and then see if I can factor. So x times x is going to make x squared. X times 5, I'm going to add 5x. And then 4 times x, I'm going to add 4x. So total, I'm going to add 9x. And then plus 5 times 4, I'm going to add 20. But then I still have to remember I'm going to minus 30. And then that equals 0. So I'm going to clean up these numbers here. 20 minus 30 is negative 10. So I'm going to try to factor x squared plus 9x minus 10 is equal to 0. And then I'm going to add 10 to both sides. Oops, I'm sorry. Actually, that's not going to work. So what I'm going to do is try to factor. So I need factors of negative 10 that add together to be positive 9. So what that tells me is I'm going to have a positive and a negative. So I'll put my x and x there. And I know that one of the terms is going to be positive, the other is going to be negative. And I do know that when I add them, the positive number has to be bigger. So to make 9, I can think, well, I could add 10 and then subtract 1 because 10 times negative 1 is negative 10, and 10 minus 1 is 9. So I can set those equal to 0. And then when I solve, I could have x plus 10 is equal to 0 and x minus 1 is equal to 0. So subtracting 10 from both sides, I would get x is equal to negative 10. And then adding 1 to both sides here, x is equal to 1. If you are ready for more challenge, try these problems out. We're not going to go over formal situations. So now we're going to revisit quadratic equations with only one solution. So it says, the other day we saw quadratic equations can have 0, 1, or 2 solutions. Sketch graphs that represent the 3 quadratic functions, one that has no zeros, one that has 1 0, and one with 2 zeros. So if I do that, remember a solution of a quadratic equation was just when it hits the x-axis. So zeros are another term for how many times it crosses the x-axis. So to have no zeros is just meaning the quadratic equation does not touch the x-axis. So it could look like this, could look like that. So this is 0 solutions. To make one solution, the graph has to just touch the x-axis once. So this vertex, or the bottom point, is just going to touch one time. So I'm just going to draw a couple in here. I have a parabola just touching once. Then I'm going to do a reflection over here. And then remember, this was a horizontal translation. I can move that over there. And then two solutions, if I sketch that. I would see that the parabola is just going to touch the x-axis twice. So I could draw something like that. So it says use graphing technology to graph x squared minus 2x plus 1. So I'm going to press the y equals, type in x squared minus 2x plus 1, and then graph it. Let me turn on my lamp to give you a better view. And I notice this looks like it has exactly one intercept. So what do the x-intercepts reveal? There is one solution. So I'm just going to write one solution. So now solve x squared minus 2x plus 1 equals 0 by writing the factored form. So we need factors of positive 1 that add to negative 2. Well, I'm going to have a negative times a negative. And the only way to make that happen is if I have x minus 1 times x minus 1 equals 0. Because negative 1 times negative 1 is positive 1. And negative 1 plus negative 1 is negative 2. So my solutions, if you look here, these are both going to make the same equation. X minus 1 equals 0, or x equals 1. And it's actually repeated twice. I could rewrite this if I wanted to as x minus 1 squared equals 0. So write an equation that represents the quadratic function you think will have only one 0. So we already said this. We could have y equals x minus 1 times x minus 1. Or we could write that as y equals x minus 1 to the second power. Let's verify that all three of those are the same. So I'm going to press y equals and then plug in x minus 1 times x minus 1. And then here, x minus 1, and then raise that up to the second power, and then graph it. And I notice all three of those are the same. So to summarize our lesson, we learned in factored form, x times x plus 4 equals 0. We could set both factors equal to 0 and solve to get our solutions 0 and negative 4. And then sometimes if we have an equation that is going to be written in standard form, we could subtract the number over on the right-hand side or set the equation equal to 0 and then factor and solve. In future lessons, we're going to learn that sometimes not all equations in standard form can be factored. So we're going to need more methods to be able to solve.